In today's video, we are going to cover adding and subtracting scientific notation. Our learning target for today is I can add and subtract numbers written in scientific notation. First, we'll look at adding and subtracting with the same powers of 10. Now, to add or subtract values written in scientific notation, the numbers must have the same power of 10. If the powers of 10 are the same, we simply add or subtract the numbers out front and keep the power of 10. We have to be careful to make sure that the number out front is written in proper scientific notation, so that is between 1 and 10. If it's not between 1 and 10, then we have to change that as well as the power of 10. Now, with different powers of 10, because of place value, if the numbers in scientific notation do not have the same power of 10, we can choose to change one of the numbers, giving it the same power of 10 as the other. Now, I like to change the smaller number to become the larger number because then I don't have to change my number in front of the power. Otherwise, if we don't want to do this, we can convert values to standard notation and then rewrite them in scientific notation at the end. Now looking at our sample problems, we're going to practice adding and subtracting with the same powers of 10. We'll write all our answers in scientific notation. Number 1, we have 6.2 times 10 to the 8th plus 2.3 times 10 to the 8th. So the first thing we want to do is identify what our power of 10 is. We can see here that it's 8, so they're both the same, so I can just add my two numbers in front. So 6.2 plus 2.3 would be 8.5, and then I would keep my power of 10. So I'd have 10 to the 8th. Number 2, we have 9 times 10 to the negative 3 minus 4 times 10 to the negative 3. Again, I want to look at my power of 10 to make sure that it is the same. If it is the same, then I'm simply going to subtract my numbers in front. 9 minus 4 is 5. So here we have 5 times 10 to the negative 3. Number 3, we have 1.9 times 10 to the negative 5th plus 5.42 times 10 to the negative 5th. Again, looking at my power of 10, I have them both as negative 5. So I'm going to add my two numbers. 1.9 plus 5.42 would give me 7.32 times 10 to the negative 5th. Looking at number 4, we have 45 million plus 23 million. This one, they're not written in scientific notation, so I can do this one of two ways. I can simply add them and then change it to scientific notation, or I can change them to scientific notation and then add them. I'm just going to add them and then change them. So 45 million plus 23 million, if I line these up, I would have 23 million here, and then I would just add the 45 and the 23. That would give me 68. So in scientific notation, that's 6.8 times 10 to the 7th. Because if I have 68 million, if I have my decimal here, I want it all the way at the end. I can see that I would carry 7 times to get to the end. Looking at 5 and 6, here we have numbers not written in scientific notation, so this time we'll change them to scientific notation and then add and subtract. So number 5, we would have 6.25 times 10 to the negative 4 minus 5.13 times 10 to the negative 4. Now when I subtract 6.25 from 5.13, that would give me 1.12, and then I'm going to keep my power of 10, so I'd have negative 4. Number 6, we have 4.5 times 10 to the negative 3 plus 2 times 10 to the negative 3. 4.5 plus 2 would give me 6.5, and then I'll again keep my power of negative 3. So 6.5 times 10 to the negative third. Now looking at number 7, we have 4.7 times 10 to the 7th plus 3.4 times 10 to the 6th. So here we have different powers. I have a power of 7 and a power of 6. So I need to change one of the powers so they are the same. I like to change the smaller power to be the bigger power because most of the time I don't then have to change my number in front. So I'm going to change 10 to the 6th to be 10 to the 7th. So 4.7 times 10 to the 7th is going to stay the same. And then my 3.4 times 10 to the 6th is going to become a 10 to the 7th. Now when I change this 6 to be a 7, I have to change the 3.4. This is actually going to change to 0.34 because if I make 6 bigger, I have to make the 3.4 smaller. So if I were to take 3.4 and move my decimal to the right, that's making my number bigger and going towards the direction that I want, in this case of the positive exponent. So my 6 would actually go to 5. So in reality, when I go to the left, that's making my number smaller and going away from the number that it actually should be, making my exponent change from a 6 to a 7. So that's why I'm making it smaller in this case and not bigger. So my new number will be 0.34 times 10 to the 7th. So I'm going to add 4.7 and 0.34, which would give me 5.04 times 10 to the 7th. Number 8, we have 9 times 10 to the 5th minus 8 times 10 to the 4th. So again, I have different powers, so I need to change them. I'm going to change the 4 to be 5. So 9 times 10 to the 5th is going to stay the same. And then my 8 times 10 to the 4th, if I make 10 to the 4th bigger to 5, I need to make my 8 smaller by moving it one base 10. That would give me 0.8. So now 9 minus 0.8 would be 8.2 times 10 to the 5th. Number 9, we have 2.8 times 10 to the negative 5th plus 5.4 times 10 to the negative 6. So again, I have powers that are not the same, negative 5 and negative 6. Now, negative 5 is actually the bigger number, so I'm going to change negative 6 to be like negative 5. So my 2.8 times 10 to the negative 5 is going to stay the same. And then I'm going to change the 5.4 to be 0.54 times 10 to the negative 5th because I made my negative 6 bigger, so I have to make my 5.4 smaller. Now I can add 2.8 and 0.54. This would give me 3.34, and then I'm going to keep my power of 10. So 10 to the negative 5th. Number 10, we have 7.2 times 10 to the negative 3 minus 6.8 times 10 to the negative 4. In this case, negative 3 is the bigger exponent than negative 4, so I'm going to change negative 4 to become negative 3. 7.2 times 10 to the negative 3 minus, I'll make my 6.8 smaller to 0.68 because I'm making my negative 4 bigger to negative 3. 7.2 minus 6.8 would then give me 6.52 times 10 to the negative 3.